Hey guys, today we're looking at solving quadratic equations and some models, which means problem solving with quadratic equations. So some equations are easy to solve, like our first example. If I have x squared equals 5, I'm just going to take the square root of both sides of the equation. So that means that x is equal to plus or minus the square root of 5. So remember when we take the square root of both sides of the equation, that's where our plus or minus has to come in. It could be positive 5, it could be negative 5, positive square root of 5 or negative square root of 5 that we ended up squaring to get to 5. We're not sure which one it was, so that's why we got to use both of them. When we write our answers, we're going to write it as x equals, use our curly brackets, negative square root of 5, comma, square root of 5. We got two answers. So we separate them with a comma, and there is our answers. Some of them require just a little bit more work. If we're looking at example 2 right here, I've got x to the fourth is equal to 4x squared. So what I'm going to do is I'm going to get everything onto the same side of the equation so I can factor. So I'm going to subtract that 4x squared over. So I have x to the fourth minus 4x squared equals 0. Then I can factor out an x squared, which leaves me with x squared minus 4. And I can factor that x squared minus 4. That's a difference of two squares, so it's going to factor as x plus 2 and x minus 2. So when I get all of those, I'm going to set all of them equal to 0 on their own. So x squared equals 0, x plus 2 equals 0, and x minus 2 equals 0. And then I'm going to solve each of those things separately. So right here, when I take the square root of both sides, I get x is equal to plus or minus the square root of 0, which is just 0. For this one, I can subtract 2 from both sides. So x is equal to negative 2. And for this one, I add 2 to both sides. So x is equal to positive 2. So I have three answers. So I'm going to say x is equal to, curly bracket, negative 2, 0, and 2. Close my curly bracket, and there's my three answers. Okay, for the next one, we've got x minus 2 in parentheses squared is equal to 16. So we want to get rid of that squared. We're going to square root both sides. So when I square root both sides, same thing as before, we got to put our plus or minus with our square root. So I'm going to have x minus 2 is equal to plus or minus, and the square root of 16 is 4. So for this one, when I have this, I'm going to have to split it into my two different options. X minus 2 is equal to my positive 4, or x minus 2 is equal to my negative 4, and solve both of those. So I'm going to add 2 to both sides here, and I get x is equal to 6. But when I add 2 to both sides here, I'm going to get x is equal to negative 2. So my answer, x equals, and then in curly brackets, negative 2 and 6. So it's not just like a positive version and a negative version of a number like our previous ones were. It's a little bit different because I had to still do some solving after I had that plus or minus there. And then probably the most common one we're used to is like example 4, where I get it all on the same side and I factor. So I'm going to subtract x and subtract 3 over. I don't really want a negative in front of my x squared. That's just my personal preference, but you could move it over and deal with the negative in front of the x squared. I'm going to have 2x squared minus x minus 3 is equal to 0. So I'm going to do my big X factoring. On the top of my big X, remember it's a times c, and my a is not 1 this time. It's 2 times negative 3, which is going to give me negative 6. The bottom is negative 1, and if a is not equal to 1, we do have to be a little bit more careful about how we factor here. So I'm still going to fill in the sides of my big X with something that multiplies to negative 6 and adds to negative 1. So that's going to be a negative 3 and a positive 2. But I'm not just going to take it over and write it in my parentheses. There's a couple different methods you could do here. You could use the box to help you. You could split the middle term. You could do slide and divide. There's a couple different things here. So what I usually do is I split that middle term. So that negative x, I'm going to take and use that negative 3 and that 2. So I'm still going to have 2x squared, but now it's going to be minus 3x and plus 2x, and then the minus 3 behind it. So I took the negative x and split it into negative 3x and plus 2x. If I combined my like terms, I would get back to that negative x, but I'm going to split it so that I can do what we call factoring by grouping, which is actually what example 5 is. I'm going to take this, I'm going to split it in half, and I'm going to see what can I factor out of the first group and what can I factor out of the second group. So if I'm looking at the first group, I can take out an x, and I would be left with 2x minus 3. And in the second group, there's not really a greatest common factor, so I'm just going to say it's a positive 1, and I would be left with 2x minus 3. So when that happens, the x and the plus 1 make their own parentheses, and then the 2x and the minus 3 make the second parentheses of my answer. Now that I have those, I'm going to take those parentheses and set them equal to 0. So x plus 1 is going to equal 0, and 2x minus 3 is going to equal 0. So I can subtract 1 from both sides here and get x equals negative 1. And over here, I'm going to subtract 3 from both sides to get 2x equals negative 3, and divide both sides by 2 and get x equals negative 3 halves. I'm sorry, you add 3 right here. Wait a minute. So 3 halves. So x equals, and then curly brackets, negative 1 and 3 halves. That would be my two answers. Ooh, I tell you guys in class all the time to be careful with your signs, and then I do the same thing right there. Make sure you be careful with your signs. If I have 2x minus 3, I've got to add 3 to both sides. Okay, so you can split the middle term and do factoring by grouping. Let's do some more practice with our factoring by grouping on example 5 right here. So remember, factoring by grouping is just splitting it into two groups and seeing what can you take out of each group. So what can I take out of the front group? What can I take out of the back group? So for this one, I can take out an x squared, and I'm left with x minus 1. In the back group, I can take out a negative 4, and I'm left with x minus 1. So when I do that, the x squared and the minus 4 make one parentheses, and the x minus 1 makes the other parentheses. But notice we're not quite done here, because this x squared minus 4 can still be factored. My x squared minus 4 can factor. It's a difference of two squares, so x plus 2 and x minus 2. Then I still have the x minus 1 behind it, and it equals 0. So that means that I'm going to have x plus 2 equals 0, x minus 2 equals 0, and x minus 1 equals 0. So subtract 2 from both sides to get x equals negative 2. Add 2 to both sides to get x equals positive 2, and add 1 to both sides to get x equals 1. So x is going to equal negative 2, comma 1, comma 2, all in our curly brackets. Got 3 answers that time. Now remember, factoring is not the only way to solve our quadratic equations. Sometimes they are not factorable. Or sometimes if you just don't want to factor, you can use the quadratic formula. So that's what we got on the next page here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you may remember the part underneath the square root is what we would call the discriminant. and it has some important features. If the discriminant is greater than 0, that means that we have two real solutions. If my discriminant is equal to 0, that means that I'm only going to have one real solution. And if it is less than 0, that means that I have no real solutions. You may remember that instead of real solutions, that's where we have I, and that's where we have our complex solutions, which we will look at when we get into another unit. For right now, we're just going to kind of focus on working with the quadratic formula. We'll get to complex numbers a little bit later in the semester. So let's get some practice with our quadratic formula. Remember, it's ax squared plus bx plus c. And so the a, the b, and the c is what we're going to plug into our quadratic formula. So x equals, if I have negative b, well, in this case, my b is already a negative 5. So it's just going to be 5 plus or minus the square root of b squared. So now it's negative 5 squared minus 4 times my a is 3 and my c is 1 all over 2 times my a, which is 3. So we can clean this up a little bit. We're going to have x is equal to 5 plus or minus the square root of 25. Negative 5 squared is 25. Minus 4 times 3 times 1 is 12 all over 6. So then x equals 5 plus or minus the square root. 25 minus 12 is 13 all over 6. And if I have the square root of 13, there's not anything else I can do with that. I don't know what the square root of 13 is. I can't simplify 13. That's a prime number. So then this would be my answer right here. You can leave it like this, or you can write it how we've been writing our answers. You can put it in the curly brackets, and you can say 5 plus the square root of 13 over 6, and 5 minus the square root of 13 over 6, or put it in the other order. So you can leave it as a plus or minus, or separate it into the plus and the minus with a comma in between them. If you're working on your My Math Lab assignment, I believe that it's going to want you to separate it with a comma in between it, but when it comes time for your test, I would take either of them. Let's look at another one. So for example 6, we're not quite in the right form. Remember, we want to be in our ax squared plus bx plus c equals 0. And you'll notice that we don't have that equals 0 part. So before I even start this one, I need to actually subtract 4x from both sides. So 3x squared minus 4x plus 2 equals 0. And now we can start plugging it into our quadratic formula. Now we have our a, our b, and our c. So x equals, negative b is going to be 4 plus or minus the square root of b squared, so negative 4 squared, minus 4 times a, so 3, times c, so 2, all over 2 times a, which is 3. Okay, let's start cleaning it up a little bit. X equals 4 plus or minus the square root of 16 minus 4 times 3 times 2 is 24 all over 6. So x equals 4 plus or minus the square root of -8 over 6. And remember, if our discriminant is negative, that means that we have no real solutions. That's where we would have complex solutions. And like I said, we'll talk about those in a later unit. Okay, the last part of today's notes is doing some word problems. So let's look at our word problems. It says a farmer wants to maximize the area enclosed by a rectangular fence. So let's draw that real quick. We've got a rectangular fence over here. He has 2,500 yards of fencing available. What is the maximum area he can enclose, and what are the dimensions of the fence? So what you have to pay attention to is it's asking what's the maximum area you can enclose. But when we're looking at 2,500 yards of fencing, that's not talking about area. That is talking about perimeter. So we have two different equations that we're going to be looking at here. So this would be my length, this would be my width. Looking at perimeter, that would be 2L plus 2W. Length plus width plus length plus width. But if I'm looking at area, that would be length times width, L times W. But what's going to happen is we're going to kind of have to set up a system of equations here to kind of help us solve it. But what I want to think about too is I'm trying to find the maximum area he can enclose. So let's kind of start with what we know. We know that he has that 2,500 yards of fencing. So I'm going to say 2,500 is equal to 2L plus 2W. I write my L's in cursive so they don't look like a 1, so I can keep it straight. And I want to take this equation and see how I can kind of maybe substitute it into my area equation. So I'm going to solve it for L. So I am going to start by subtracting 2W from both sides. So 2,500 minus 2W is equal to 2L. And then I can divide everything by 2. So now I get 1,250 minus W is equal to L. And now I'm going to take this that equals my L, and I'm going to plug it in to my L up here in my area. So we're going to plug it in right here. So now my area is going to equal 1,250 minus W times W. I can distribute that. So my area is equal to 1,250 W minus W squared. And we did say we're working with quadratics in this unit and working with quadratics today. So that squared is kind of how we get to a quadratic. So let's think about what we know about quadratics and how we can find a maximum there. So if we're looking at this quadratic, I could rewrite it so it's negative W squared plus 1,250. We talked in the last set of notes about what quadratic graphs would look like. So for this one, it would make a parabola shape like the rest do. And we do have a negative in front of my squared term. So that does mean that it would make a downward facing parabola. So my vertex would be the top point, or another word for that is max. So my vertex is my max. So to figure out what the maximum area is, I just need to find my vertex. So to figure out all of this, W is going to be that negative B over 2A that we used in the last set of notes. So remember, we've got A x or W squared plus BX plus C. And it looks like my W got erased here. So W's are my X's in this case. So if I'm looking at negative B, that would be negative 1,250. And I'm going to divide it by 2 times my A, which is negative 1. So negative 1,250 divided by negative 2 means that my width is 625. The negatives cancel to give me a positive 625 yards. So then my length, I'm going to use this equation. L is equal to 1,250 minus W. So L is 1,250 minus the 625. So my length is also 625 yards. So I found my dimensions. There's my length. There's my width. The last thing that I need to find is my actual area. So to find my area, I'm just going to multiply them. And when I multiply those, I get 390,625 yards squared. Okay, we got one more to look at. It's kind of similar. There's just one little difference. The farmer wants to build a fence to make a pen next to his barn. If we're making it next to his barn, that's where we get a little bit different. So let's say his barn is over here. I'm not good at art, so please don't judge my drawing. If this is his barn, his pen is going to go right next to it. So for this pen, instead of having all 4 sides, this time we're just looking at 3 of them. So when I'm looking at my area and my perimeter, the area pretty much stays the same because area is still length times width. My perimeter now is 2L plus W. So it changes a little bit. So this one says he has 102 meters of fencing available for the fence, and we're still trying to find the maximum area. So let's kind of break it down. So I'm going to have 102 is equal to 2L plus W. I want to solve this one for W because it doesn't have a coefficient in front of it. So I'm going to subtract my 2L from both sides. So 102 minus 2L is equal to W. And then I take that and just plug it in for W. So my area is going to be L times 102 minus 2L. Distribute that. So 102L minus 2L squared. Okay, and same idea as what we were talking about with our quadratic up here. Since it's a quadratic, and it's negative 2L squared plus 102L, our A value is negative, so it does make a parabola that faces down, and our vertex would be a max. So my L, my length, is negative B over 2A. So my length, keeping in mind this is ax squared plus bx plus c, would be 102 negative over 2 times negative 2. So negative 102 over negative 4, which would be 25.5. So my length is 25.5 meters. To find my width, I'm going to come plug it back in over here. 102 minus 2L. So my width is 102 minus 2 times that 25.5. So 102 minus 2 times 25.5 is 51. So my width would be 51. 102 minus 51 is 51 meters. Okay, and then to find my area, I'm just going to multiply those together. So 51 times my 25.5 means that my area would be 1,300.5 meters squared. So the key here is to make sure you're paying attention to the wording. If you're making the pen next to the barn or like next to a river or something like that, that means you're only going to have 3 sides to the pen versus up here where you have all 4 sides. And then you've got to remember what you know about quadratics and how to find your vertex and whether it's a minimum or a maximum and what you're trying to do here. This would come in handy in calculus when you get to optimization, which is something that you'll probably get into if you take calculus AB in the second semester, and if you take calculus BC, probably towards the end of the first semester. So this would be something that you would look at in calculus on a slightly more difficult scale. Great, that's it for this set of notes. Let me know if you have any questions and get started on your assignment. You guys have a good day.